Okay, so we've got the section there showing the brickwork under the windowsill, and if you haven't added this, well, I was going to say plinth, it's windowsill, then you could do it as I have with a fairly nominal thickness. 80mm is what I've worked it out to be, and I've just drawn it rectangular. We can always slope that. There's got to be something wrong with our measurements, because what we're getting from the outside is slightly different to what we're getting from the inside, but it's close enough for now. So I basically draw an 80mm high rectangle that is simply the width of the brickwork. And now I want to put in the slab below the bricks, and so I've deleted everything from there just so that I can show you how to draw it all from scratch. Fairly straightforward. I've got a layer for my in this file, yes I do, a layer for my floor concrete, and then I'm going to draw a line from the end of my floor line, which extends all the way to the brickwork, end of the bricks. So it could be from the end of the brick line there, either way. It's really important that you understand how object snap works when you're doing things like this, because if you have an option like nearest turned on, which I know a lot of people seem to fall back on, then it will snap to anywhere on the line. So I usually just make sure that is turned off, and then when you move to a line like this, it should easily be able to pick up the endpoint even if you're not close to the endpoint. And you can see there, hopefully, that I've got the endpoint symbol coming up with the square on the end of that line, and then I'm going to simply turn on ortho, take my line down and type in the distance I've worked out, which is 120. It may be slightly different, but it's close to what's really there. And I'll just get some photos so you can see what we're looking at. Okay, so you can see there, projecting across, it's about 1.5 bricks. Or even just visually here, you can see, if you compare that distance to here, it's about 1.5 brick courses. So again, around 120. And then now I'm going to go and make sure polar's turned on, polar tracking, and get it to snap to 45 degrees next to ortho. Now if you don't get it to snap to that angle, you can check your polar settings and make sure they're in increments that will give you 45 degrees. So it could be 5, could be 15, but not 10 or 23 or 30. None of those are going to snap to 45. But 5, of course, times 9 is 45, 15 times 3 is 45. Any of those will give you 45. Okay, so coming down here, I'm not worried about the length. I'm just going to draw a line, making sure it's 45 degrees. Click. And then I'm going to come back and draw a new line, starting from the inside face of my wall above. Take it straight down, so it snaps to vertical. And now we'll look at the photo again. So the beam there, the perimeter beam, you can see is, well, let's count them, 1, 2, 3, 4, 5, 6, 7 courses. Remember, what, 7 courses? Exactly, 600. So when you see 7, you can usually assume 600, which makes life easy. So here we go, offset 600 from this line down. So that gives us the bottom of the beam, and I can fillet that now to join those lines together at the corner. How wide do you think the beam is? No, because I just drew that at an arbitrary length. Yeah. So you remember though, you measured the column. Yes, the width of the column. I'm pretty sure we can. Well, if it's not, we can draw it that width for now. Might need to change it, but I'm pretty sure it is the width of the column. Okay, so that was 360 from memory. So if you offset this line 360 to the left, and then you can just fillet those lines together. There we go. So then, do you have any idea about the slab thickness for the floor? Or would you know how you can try and find that? You'd walk past it every day. Yeah, it wouldn't be less than 300. 300 is very thick, and you want to probably get a rough idea about some common slab thicknesses. So anything over 200 is quite thick, actually. And you'd be surprised how thin they can be. Concrete, reinforced concrete, is capable of spanning pretty reasonable distances. So concrete on its own, without steel in it, is hopeless, and it can't span very far at all. But with the steel, it's quite a good, strong tensile material. In other words, it can span quite a long way. So you'd be surprised. I've done concrete suspended floors 120 thick. But this one, I've measured, it's 150. And you can measure it, you can see it for yourself. If you look in the fire stand, you'll see there is part of the slab exposed. Okay, so we can just assume it's 150. May not be that thickness all the way through, but we can just assume that for now. So I'm just going to offset down 150 from the floor line, fillet those together, and we can add the chamfered edges later. So there are quite a few chamfered edges, and it would be nice to have those as well. So here at the front you can see we've got one, and there's probably one on the other side of the column, but again we'll add those later. No, but I'd keep that as a reference for yourself. Yeah. This one, though, is what you should have for your drawings, yeah. So then the final finishing touch that'd be nice is to add another layer. So here I've got a floor concrete layer, which is for concrete when it's being cut. So I'm going to add another layer, a floor concrete projection, just P-R-O-J, oops, if I can spell, which here is just like my concrete projection layer for the columns, and I'm going to make that have a lighter line weight, 0.15, maybe even lighter, 0.15 probably okay, and I'll give it a different colour, just a different green, make it current, or just any green different to the previous one. 0.15. Sure. And so I'm going to draw a line down from each of the corners here, just to indicate that we have a column that's supporting the beam. Right, so can you see how much clearer that is? We can see that's with a lighter line weight behind this part, the beam and the floor that are being cut. And before long you just will read that naturally. Anything with a lighter line weight, you'll automatically think that's behind the things that are being cut, which are in the foreground. Even though, of course, in reality that's not the way it would look. If you cut through it, the line weight, of course, wouldn't be there. But again, before long you just think the line weight naturally is heavy when something is cut. So that's the way you want to be reading your drawings, and hopefully that reads clearly as a column. And yeah, so we'll have a look at doing the windowsill and then go up to the beam above and do the ceiling as well afterwards.